Welcome back to our video series, Everything About Public Schools. My name is Blaine Helwig. Today's focus is the math topic, fractions represent two things. The video will delve into fractional numeracy from both a state standards perspective as well as a required mathematical understanding for students pursuing careers in STEM fields. I'm pleased you're joining us. The video, Fractions Represent Two Things, is primarily intended for 4th grade through 8th grade students. However, the process described in the video may be helpful to high school teachers tutoring students with academic skill gaps. There is a free downloadable PDF with commentary and all the skill resources referenced in this video at the website thenewthree-rseducationconsulting.com under the video tab. Or simply Google my name, Blaine Helwig, and follow the links to the website. Let's hop right in. Part 1, Teacher Content. It's recommended that educators work the numerical examples in this section simultaneously with me. Please stop the video as needed. In general, a teacher should practice content thoroughly so they are aptly prepared in sequencing, content, and verbiage when conducting instruction during core lessons, mini lessons, or spaced repetition. All fractions represent two things. 1, part of a group, and 2, a division problem. It's important to note that the division problem meaning requires students possess complete mastery of their math facts. This numeracy process is shown in the video, Math Fact Mastery, Easy to Do. Please check it out. Before we hop into the examples, let's get everyone on the same page with fraction, mixed number, decimal, and percent vocabulary. Why? Recognition of these elements will be key for students to recognize next steps on conversions, but it also helps them to mentally map where these fractional elements are physically located in relation to one another. So let's begin with the most basic fractional form. Let's use 3/4 as our example. The 3 is in the numerator, and the 4 is in the denominator. The numerator tells us how many equal parts are shaded, or the number of equal parts that we are interested in, whereas the denominator indicates the total number of equal parts. There are two types of fractions, proper and improper. A proper fraction is less than one whole. Thus, the denominator is greater than the numerator. Examples include 5/10, 1/2, and 71 thousandths. An improper fraction is greater than or equal to one whole. In this case, the numerator is greater than the denominator. A couple examples of improper fractions are 11/10, 8/5, 3/3, and 7/2. It's essential that students recognize by sight if a fraction is either a proper fraction or an improper fraction, as we will soon see. A mixed number contains both a whole number and a proper fraction. Let's look at a couple examples. 4 1/10, 8 3/7, 1 57/100. A decimal is a real number rooted in base 10 mathematics. Examples of decimals are as follows. 3.01, 12 8/10, 4 56 thousandths. A percent means per 100. This arithmetic element is included in this video since it's an application of fractions and decimals and is ubiquitous in everyday life. Here are some examples. 30%, 61%, 2%, and 100%. All fractions, both proper and improper, represent two things. 1, part of a group. 2, a division problem. Let's illustrate this dual nature of fractions with two examples that cover both base 10 and non-base 10 denominators. Example 1, proper fractions. These are fractions that are less than one whole, meaning that the denominator is greater than the numerator. Part A, a proper fraction with a base 10 denominator. Let's use the fraction 5/10. The part of the group solution, the denominator of the fraction is divided into 10 equal parts, or tenths, and 5 equal parts are shaded, its numerator. Hence, our part of the group solution is 5 equal parts of interest out of a total of 10 equal parts. Second, let's look at the division problem representation. First, students need to recognize that this fraction, 5/10, is a proper fraction, meaning it's less than one whole. Then we roll our fraction to the right. The numerator becomes the dividend and the denominator is now the divisor. We can begin dividing. But our first digit in the quotient is 0, since we are dealing with a proper fraction that is less than one whole. Then we simply carry out the divisional process. Finally, we write our equivalency. It is important that students do this last step. It presses the mathematical equality of the process. Example 1 continued, proper fractions. Part B, a proper fraction with a non-base 10 denominator. Let's choose the fraction 2/5. The part of a group representation. The denominator of the fraction is divided into 5 equal parts or fifths, and 2 equal parts are shaded, its numerator. An important note, when I'm teaching, I tend to gravitate to circle pictorials frequently because it's quick, but I recommend varying the part of a group representation with squares and other objects so students do not get locked into circles. For example, so our part of the group solution is 2 equal parts of interest out of a total of 5 equal parts. Now, the division problem representation. Students must immediately recognize that 2/5 is a proper fraction. Please emphasize this point in your teaching. Next, we roll our fraction to the right. The numerator 2 becomes the dividend, and the denominator 5 is now the divisor. We can begin dividing. But we know the 5 does not go into 2, and our first digit in the quotient is a 0, since we are dealing with a proper fraction that is less than 1 whole. We continue and complete the division process. Lastly, we write our fractional decimal equivalency that tells students this is what it means when we divide a fraction to an equivalent decimal. It leaves no doubt on the mathematical objective. Example 2, improper fractions, fractions that are greater than or equal to 1 whole. Part A, an improper fraction with a base 10 denominator. Let's select the fraction 13/10 as our example. Number 1, part of a group representation. The denominator of the fraction is divided into 10 equal parts or tenths, and 13 equal parts are shaded, its numerator. Visually, our fraction is clearly greater than 1. Consequently, our part of the group solution is 13 equal parts shaded out of a total of 10 equal parts. Next, the division problem representation. I will only illustrate the decimal solution in this example. Students must immediately recognize that 13/10 is an improper fraction. We roll our fraction to the right. The numerator 13 becomes the dividend, and the denominator 10 is now the divisor. We can begin dividing. But we know that 10 does not go into 1. I put an X on that line as a placeholder, and our first digit in the quotient is 1 since we are dealing with an improper fraction. We continue and complete the division process. We end our work as always by writing the fractional decimal equivalency. Example 2, improper fractions continued. Part B, an improper fraction with a non-base 10 denominator. As an example, let's use the fraction 7/4. First, the part of a group representation. The denominator of the fraction is divided into 4 equal parts, or fourths, and 7 equal parts are shaded, its numerator. So our part of the group solution is 7 equal parts shaded out of a total of 4 equal parts. Second, the division problem representation. As in the previous example, only the decimal solution is shown. We roll our fraction to the right. The numerator 7 becomes the dividend, and the denominator 4 is now the divisor. We continue and complete the divisional process. Finally, we write the fraction decimal equivalency. As a visual summary of the work thus far, let's look at a proper and improper fractional pedagogical tree diagram. First, proper fractions. These are fractions that are less than 1 whole. A proper fraction can be represented by part of a group. A proper fraction can also be represented by a division problem. This always yields a decimal as a finite solution. Second, improper fractions. In this case, fractions are always greater than or equal to 1 whole. As with proper fractions, there are 2 representations. An improper fraction can be represented by part of a group. An improper fraction can also be represented by a division problem. But it gets a little bit more complicated since the division process can yield either a mixed number or a decimal solution. Teachers should know these simple fraction schematics to mental automaticity for clarity of their lesson design and sequential instructional process. Percentages are everywhere, and it's an application to the work in this video. Plus, it's easy for students to learn. If given a fraction, it's easy to calculate a decimal and compute an equivalent percentage. Why? Decimals and percentages are both base 10 number systems. In fact, percentage means per 100. Let's work a quick example of computing a percentage. Given the proper fraction, 4/5, let's compute an equivalent decimal to the fraction 4/5 by division. And we obtain a quotient of 0.8. Thus, 4/5 is equal to 0.8. But percent means per 100. As discussed in an earlier video, we know we can add a 0 after the decimal point and not change the overall value of the decimal. So let's convert 0.8 or 0.80 to a proper fraction with 100 as a denominator. We can use our 1 under the decimal point and add zeros under each digit to the numerator to simulate a fraction. Now we have a fraction that is 80/100ths per 100. Consequently, another way of saying 80 over 100 is 80%. Part 2, Instructional Content, Sequencing, and Teaching Tips. It is recommended that educators work the numerical examples in this section concurrently with me. Please stop the video as needed. All fractions, both proper and improper, represent two things. Let's work 4 examples with students as our target audience. Example 1. Let's use 1/4 as our fraction. First, part of a group meaning. The denominator tells us there are 4 total objects. Our fraction is divided into 4ths. The numerator indicates that there is 1 object shaded, or that we only have 1 object out of 4 that we are interested in. Second, the division problem representation. Rolling the fraction 1/4 to the right, we see the numerator 1 becomes the dividend, and the fraction's denominator 4 transforms into the divisor. We recognize that our fraction 1/4 is a proper fraction, so it's less than 1. Thus, the first digit in the quotient is 0. Then we can complete the division process. Let's plot a quick number line to ensure students understand the physical nature of the mathematics. This visual exercise cements the entire process into long-term memory. Now, let's add in our whole numbers, 0 and 1. The denominator is 4 in 1/4, so we have 4 equal spaces between the 0 and the 1. When students first start this activity, it's recommended that they count the spaces so they create the same number of equal spaces as indicated by the denominator between the two whole numbers, in this case 0 and 1. Let's add in our proper fractions beginning with 0/4. Then, above the number line, we add our equivalent decimals to the mix. Start with 0 and count by multiples of 0.25. Circle the equivalency so the equality is crystal clear to students. The decimals 0.25 and 1/4 occupy the same point on the number line. Write the equivalency to leave no doubt on the objective of our exercise. It's also possible to show students the part of the group solution on a number line. For instance, there are 4 equal spaces, the denominator, and we are interested in one of them, the numerator. Example 2. Let's do another proper fraction. This time, let's use 3/5 as our example. First, part of a group meaning. The denominator tells us there are 5 total objects. The numerator indicates there are 3 objects that we're interested in. Second, the division problem representation. Rolling the fraction 3/5 to the right, we see the numerator 3 becomes a dividend, and the fraction's denominator 5 is transformed into the divisor. We recognize that our fraction 3/5 is a proper fraction, so again it's less than 1 whole. Thus, the first digit in the quotient is a 0. Then we can complete the division process. Let's plot a quick number line. Add in our whole numbers 0 and 1. The denominator is 5, so we can add 5 equal spaces between the 0 and the 1. Add in our proper fractions beginning with 0/5. Then, above the number line, we add in our decimals with multiples of 0.2. Circle the equivalency so the equality is obvious. the decimal 0.6 and 3/5 occupy the same point on the number line. Write the equivalency. 3/5 is equal to 0.6. Optionally, the teacher can show students that part of the group solution holds on a number line. For instance, there are 5 equal spaces, the denominator, and we are interested in 3 of them, the numerator. Example 3, transitioning to improper fractions. Let's choose the improper fraction 5/3. First, part of a group meaning. The denominator tells us our fraction is divided into thirds, but there are 5 equal parts in the numerator. Therefore, our fraction must be greater than 1 whole. Second, the division problem representation. However, it's a little more complicated since improper fractions have 2 possible equivalencies, a mixed number and a decimal. The mixed number is always the easiest to calculate. Roll our fraction to the right, the 5 becomes a dividend and the 3 becomes a divisor as before. We divide. And compute a mixed number 1 2/3 as a quotient. Next, we repeat the process for the decimal equivalency. We roll the fraction to the right and complete the division process. It's clear that the division process will go on to infinity by continuing to add 6's in the quotient, so we place a bar over the repeating numbers in our quotient. Let's plot a quick number line. Add in our whole numbers, 0, 1, 2. The denominator is 3, so we have 3 equal spaces between 0 and 1 and 1 and 2. Add in our proper fractions, beginning with 0/3. Above the number line, we can add our equivalent decimals by multiples of 0.33. Above the decimals, beginning at 1, we include our mixed numbers, starting with 1 and 0/3, and so forth. Circle the equivalency. 1.66, 1 2/3, and 5/3 all occupy the same point on the number line. Let's write the equivalency. 5/3 is equal to 1.66, which is equal to 1 2/3. As in the previous examples, a teacher can show the students the part of the group solution on a number line. It's a little more complicated, but it works. There are 3 equal spaces, the denominator, and we are interested in 5 of them, the numerator. With short daily mini lessons each morning of about 6 to 10 minutes, students master this exercise in its entirety. Example 4, another improper fraction. Let's choose 3/2. Part of a group meaning? The denominator tells us our fraction is divided into halves, but there are 3 equal parts shaded in the numerator. Our fraction must be greater than 1 whole. Second, the division problem representation. Again, 2 possible solutions, a mixed number and a decimal. Let's do the mixed number first. Roll our fraction to the right. We compute the mixed number through a quick division process. And we obtain 1 1/2 as a quotient. Next, we repeat the process for the decimal equivalency. We roll the fraction to the right and complete the division process. Our decimal equivalent is 1.5. As in our previous examples, let's plot a quick number line. Add in our whole numbers, 0, 1, and 2. The denominator is 2, so we have 2 equal spaces between the whole numbers. Add in our proper fractions, beginning with 0/2. Above the number line, we can add our equivalent decimals. Above the decimals, beginning at 1, we include our mixed numbers starting with 1 and 0/2. Circle the equivalency. The decimal 1.5, 1 1/2, and 3/2 all occupy the same point on the number line. Let's write the equivalency. 3/2 equals 1.5 equals 1 1/2. The part of the group solution on the number line indicates the following. There are 2 equal spaces, the denominator, and we are interested in 3 of them, the numerator. Proper and improper fraction teaching tips. I write 3/10 on the whiteboard and ask my 5th grade students, tell me everything you can about this fraction. In response, I hear the following. It's a proper fraction. The numerator is 3. The denominator is 10. The fraction is divided into tenths and 3 parts are shaded. The fraction is less than 1. The equivalent decimal to the fraction is 0.3. The fraction is 3/10 away from 0. The fraction is 2/10 away from 1/2, and 7/10 from 1. I engage in a very rapid mini lesson each morning for 3 to 5 minutes until every student masters the content. I write 4/5 on the whiteboard and ask my 5th grade students, show me with your fingers how many ways this fraction can be represented. In response, I see 2 fingers. I add, write those 2 things in your math notebook. In response, I read part of a group and a division problem. I do this very rapid mini lesson format each morning until every student can correctly answer the questions. After my 5th grade students have been thoroughly taught the part of a group and division process on proper and improper fractions, I ask them, show me the 2 ways that the fraction 2/5 can be represented. In response, I see the part of a group representation, 5 total objects of equal size with 2 objects shaded. The division representation, the proper fraction is rolled to the right and correctly divided to compute an equivalent decimal quotient of 0.4. I also see the equivalency written 2/5 is equal to 0.4. Draw a number line and show me your solution. In response, I see a number line that is correctly divided in fifths, showing that the decimal 2/5 is equal to 0.4. I do this very rapid mini lesson every morning for 3 to 5 minutes until every student can do it correctly. However, I have taught the math processing skills that ensure my students all possess mastery of required background knowledge needed for the success in this activity, as well as the 4 math fact operations. Otherwise, classroom instruction is a hot mess with students not understanding basic arithmetic concepts during the core lessons. In the situation of unprepared skill-based students, the classroom modus operandi instructional model evolves into the pragmatic philosophy: if the students are skill-based prepared, they get it. If they are not prepared, they don't get it. A quick recap of the video's 4 main points. Point 1. All fractions, both proper fractions and improper fractions, represent 2 things: part of a group and a division problem. This allows students to A. compute equivalent decimals from proper fractions, and B. compute equivalent decimals and mixed numbers from improper fractions. Point 2. Always show students both elements of the fractional representation each time an example is presented. Then, plot the results on a number line to ensure that students grasp the physical nature of the mathematics. Point 3. Students must know their math facts to automaticity, or the division part of the solution will cognitively overwhelm a vast majority of children. Point 4. This content is essential numeracy skills for a STEM education. Thus, teachers must provide threshold repetition so students master the content. Thank you for watching. I hope this short video was helpful in your work in the public schools. Please check out our other videos and resources.